Okay, let's start topic 4 lecture. So today we will first start review topic 3. So we will briefly wrap up this topic 3 and then we will move on to topic 4. Okay, so let me spend some time to review what we have learned in topic 3, the measures of central location, measures of variability, and measures of the relationship between two variables, right? Measures of the linear relationship between two variables. Okay, so then we will move on to topic 4. So let's try to think about what we have learned. So first thing what we have learned was the measures of central location, right? Measures of central location. For measures of the central location, we have learned mean, right? Mean and median and the mode, right? Mean, median, and mode. What does the mean? Mean, there are two means that we run. First one was the population mean, right? Population mean, which is 1 over capital N. Actually, let me say mu first, right? Mu, population means mu, right? Mu, which is 1 over capital N, summation I equals 1 to capital N, xi, where xi, x1 to xn is basically all those possible observations, units in sample, in the population, from 1 to n, right? 1 to n in the population, and then there is one variable such as heights or weights or wage. And then x1 is basically the first person's wage, xn is the capital N, x capital N is the nth person's wage, and so on, right? And then there are some, and we add them up, and then we divide by n, right? Capital N. Then this is going to be population mean, and there is also what the sample mean, right? Sample mean, which is x bar. 1 over small n, summation I equals 1 to n, xi, right? And the population mean and the sample mean. And then the next thing was the median, right? Median. Basically the middle value, right? Middle value, the 50% of the observation should be the left, so lower than this median value. And the other 50% should be higher than the median, right? Median here, if median is here, median is here, then 50% of the observation should be lower than median, and another 50% should be higher than the median, right? And then, for example, if the data or the values in the variable takes 0, 1, 2, 4, 7, 9, 10, this is the data of a variable, then there are 3 values here, and there's another 3 values here, and this 4 should be the median, right? Median. If there are odd number of observations, then we can pick exactly the middle number, which becomes the median. If there are more than if there are actually the even numbers, for example, like 0, 0, 1, 2, 4, 7, 9, 10, 7, 9, 10, then the median is basically there are 3 here and 3 here, and there are 2 numbers, so we have to get the median. Say x med is 2 plus 4 divided by 2, which is 3, right? 3 is the median. If there are even numbers of observations, then we pick 2 numbers in the middle, and then we add them and divide by 2. That's how we get the median, right? And then the mode, what is the mode? Mode is the value that is most frequently occurred. So the value that occurs most frequently. So in this case, mode is 0, right? Because 0 occurs twice and the other numbers occurs only once, right? And you have to think about which one is the best one. So mean, median, mode, which one is the best? Okay, which one is the best? It depends on whether there is outlier or not. So if there is outlier, median may be the best. If not, then maybe the mean may be the best. Okay. That's the measures of central location. Let's think about the next topic where we have discussed in topic 3. The next topic was what? Next topic was the measures of variability. Right. The first measure we have discussed was range. Range is what? Range was x max minus x min. Basically, the maximum value minus the minimum value, right? And then next one we talk about was variance. Variance. There are two things in the variance. Variance. One is the population variance. Population variance. Sigma square, right? 1 over capital N summation I equals 1 to N, 1 to capital N xi minus mu squared. So basically counting the distance between a particular value, and minus is mean, and you take a square and we add them up and we divide by n, right? Then that becomes the population variance, right? Population variance. And the sample variance, interesting thing was the sample variance, right? Sample variance s squared, which is 1 over n minus 1, right? 1 over n minus 1 summation I equals 1 to small n xi minus, instead of mu is unknown, right? This mu is unknown. So we replace this mu with the x bar, sample mean, and we take a square and we add them up, the distance, square distance, we add the square distance, add up those numbers, and then we divide by n minus 1, right? Why we divide by n minus 1? Basically, the main reason is we want to find the unbiased estimator. So later we will learn the concept of unbiased estimator. Basically, this guy will be unbiased estimator by dividing by n minus 1 instead of n. Okay, that is the main thing. Unbiased estimator for sigma square. Okay. So population variance, for population variance, this S square is the unbiased estimator. Okay. And then what else? Then what we have learned was the population standard deviation. So basically standard deviation. And same as the population variance and population mean. There's population standard deviation, standard dev. Okay, standard dev. Let me just use abbreviation. Sample standard deviation is here. Population standard deviation is sigma, which is the square root of sigma square. Sample standard deviation is S. S is square root of S square, right? So that is the population standard deviation and sample standard deviation. Okay, and basically this standard deviation has the same unit of measurement, as x, right? X, but the population variance or sample variance is squared. So unit of measurement is actually much bigger than the unit of measurement of the x. Okay, that's what we have learned as a measure of variability. And then next thing that we have learned was the empirical rule. I'm not gonna spend too much time on reviewing this empirical rule. Empirical rule means one, if histogram, if a distribution or histogram is bell-shaped, then 68% of all the observations fall within one standard deviation. So mu plus minus one standard deviation, 68%, or x bar plus minus one standard deviation, x bar plus minus one standard deviation. There are 68% of observations And 95% of all observations are within basically mu plus minus 2 sigma, right? 2 sigma. So mu minus 2 sigma, mu plus 2 sigma, or x bar minus 2 sigma, 2s, x bar plus 2s. And the 99.7% observations are in 3 sigma, mu minus 3 sigma, mu plus 3 sigma, or x bar minus 3s, x bar plus 3s. That is the empirical rule. If the distribution or histogram of a certain variable is bell-shaped symmetry, right, and unimodal, then 68% of observations are within 1 sigma around the mean, right? Mean plus 1 sigma and mean minus 1 sigma, right? That range. And 95% observations are fall within 2 sigma. And 99.7% observations are within 3 sigma, okay? Plus minus 3 sigma, okay? That is the empirical rule. Okay, and then the next thing we learned in chapter 3 was measures of relative standing. This one I also don't want to spend too much time reviewing this relative standing. Basically, percentiles, quartiles, and so on. And dociles, for example, like docile is 10%, 20%, and so on, dociles, and so on. Those kind of things that we can think about, right? And then the maybe more important thing is measures of the linear relationships, measures of linear relationships of between two variables, two variables. It's hard to write English well with this iPad relationship between two variables. So the thing we learned in this category was covariance and correlation. They are very important. These covariance correlation is super important. And coefficient of determination, which is relatively less important. Coefficient of determination. I will just review for the first two. Covariance is what? Covariance, there's also population covariance. Sigma xy, which is 1 over n, summation I equals 1 to capital N, xi minus mu x times yi minus mu y. So how x and y co-varying, how x and y varying together in the same direction or in the different direction in the linear way, right? And the sample covariance s xy, which is 1 over n minus 1, right? 1 over n minus 1, 1 over n minus 1, summation I equals 1 to small n, xi minus, again, this mu x, mu y. By the way, this mu x is what? Mu x is the sample mean of x, the population mean of x. Population mean of x, right? So we have to replace this population mean with the sample mean x bar, yi minus y bar, okay? So we don't know population means, so we have to replace those population means with the sample means, okay? And correlation, let me say population correlation, low xy, okay, low xy, this is low, right? Low xy is what? sigma xy, the population covariance, divided by population standard deviations product of the two population product. There's population correlation and sample correlation. Sample correlation is what? Sample correlation is R or RXY. This is SXY, which is sample covariance divided by sample, the product of the sample standard deviations. Sample standard deviations. So that is the sample correlation. So if two variable has a linear relationship, then this sample correlation or population correlation is between this value. Basically, this value is between 0 and between -1 and 1. Between -1 and 1. If they have strong positive relationship, then closer to 1. Strong negative linear relationship, then close to -1. This is a strong negative linear relationship, right? And this is strong close to 1, 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 strong positive linear relationships, close to -1, then strong negative linear relationships. Okay, so let me delete this. Okay, strong positive linear relationship, strong negative linear relationships. Okay, so correlation basically captures this kind of relationship between two variables basically x and y. Okay, that is pretty much the whole review of this topic 3, and let's move on to topic 4. Okay, topic 4.